Alright, so this is lesson 8 for chapter 2. We're going to start looking at square roots of rational numbers. So by the end of this lesson, I'm hoping you remember what perfect squares are, the difference between perfect squares and non-perfect squares and rectangles, just like from lesson 7. And we are going to use our perfect square table to help estimate the square roots and calculate the square roots of non-perfect squares. So your first example says, Lisa was asked to calculate the square root of 64 on an exam. Here is her completed solution. 32 plus 32 equals 64. So this means the square root of 64 is 32. So I would like you to figure out what is wrong with her solution and write it below. So pause the video, write it below. We're going to check this in class tomorrow. Okay, so your first example that we're going to walk through is the square root of 45. So it says calculate the square root of 45 to as many decimal places as your calculator shows. So in my calculator, when I type square root of 45, why are we not working? Let's try that again. Okay. As you can see, the smartboard's acting up. So we'll erase that one. Let's try that again. Square root of 45. When I enter that in, I get 6.708203932. That's with all the decimal places. Your calculator might show something different. So then if I went this number times itself, so 6.708203932 times 6.708203932, I end up getting 45. Okay? And so basically it's saying that this number is the factor of one of the factors of 45, or it's the square root of 45. But hopefully you notice that this decimal is not a rational decimal. It's irrational. It does not follow a pattern, and it does not end. So if my calculator screen was longer, I would see more decimal places. And so this is an estimate. This number actually continues on. It's an irrational decimal. So 45 we would say is a non-perfect square. Okay, so carrying on and looking at our next example, it says, Milhouse's calculator says that the square root of 33 is this big long decimal. Again, we have an irrational answer because it does not end and it does not repeat. However, when he types that factor times itself, so 5.7 times 5.7 he gets 33.00001. And it asks, is his calculator broken? Well, we know that perfect squares have whole number rational answers as their square roots. So 33, when we square root it, we get a number that is not a whole number. It is not a rational number. The decimal does not end or follow a repeating pattern. And so it is a best estimate. This decimal continues on, just like the last example. It continues on. And so it's only an estimate. So it's almost been rounded. Maybe that 7 at the very end has been rounded up from a 6 on his calculator. So his calculator is not broken. It is rounded. The irrational square root. Okay, so 33 is a non-perfect square, so we have an irrational square root. So at the bottom of your page, you see a box that says important perfect squares. So this is an important table that you should make. And so we have perfect squares, and then the square roots of those squares. So, for example, if I had a square that had an area of 1, the square root is 1. If I had a square of area of 4, the square root is 2. If I had square area of 9. The square root is 3. So I want you to continue this table all the way up to 12. So you can fill that in for yourself, and we're going to have a version of it up in the classroom tomorrow that you can double check. So if you could pause and fill in that part of your notes, and then we'll move to the next page. Okay, so it's asked us to estimate the following square roots. Generally, if we're asking to estimate, it means because the square root we are looking for is a non-perfect square. And 34 is not a perfect square. So if I refer to my perfect square table that I just filled in on the bottom of the last page, we said that some of the squares, perfect squares we have are 4, 9, 16, 25, 36, 49, 64, 81, 100. And so when I look at 0.34, I'm going to think of it just as 34 for a minute. And so 34 is not a perfect square. It's not one of these numbers. It's going to be in between two of my perfect squares. And so 34 falls in between 25 and 36. So it's between the perfect squares, 25 and 36. Okay, but 34 is much closer to 36. So the square root of 25 is 5, and the square root of 36 is 6, and it's going to be somewhere in between. But we said it's going to be somewhere closer to 6 because 34 is closer to 36. So I might estimate something like maybe it's 5.6 or 5.7 or 5.8, somewhere in there. So I'm going to estimate that it's 0.56. And to double check, I'm going to type in my calculator, square root 0.34. Okay, and I get 0.583, so it is irrational, 0.583, etc. So 5.6 was a bit of a low estimate, but it's not too far off. When I look at the second example, I'm looking at 73, ignoring the decimal for now. And 73 is not a perfect square, and so I want to look on my perfect square table and see where does it fall. And so 73 is going to fall in between 64 and 81. Okay, so it's between 64, 64 and 81. It's somewhere in here. And the square root of 64 is 8. The square root of 81 is 9. And so 73 is going to be in between those two. Well, 73 is closer to 81. It's 11 away, or pardon me, 9 away from 64. And 8 away from 81. So it's closer to 81. And so that means it's going to be closer to 9 again. So it's going to be somewhere here. So maybe I'm going to guess 70, or pardon me, 8.5 or 8.6. I'm going to do 8.6 because it's a little bit closer. 8.5 would be exactly in the middle, and it's not quite exactly in the middle. So I'm going to guess 0.85. And so in my calculator, I type 0.73 square root, and we get 0.8544. That's what we got. Okay, it's again an irrational number. So we're estimating, and we double check by calculating in the calculator. So now I say find a number which has a square root in between 3.5 and 4.5. Okay, well, that should be pretty easy. We're looking for a number that has a square root between 3.5 and 4.5. So let's pick the whole number that's in between them. So we have 3.5, and then we have 4, and we have 4.5. So we need a number that has a square root between these two. So if this is the square root, the perfect square, would be 16. So 16 is our number that has a square root between 3.5 and 4.5. So this is our square root. When we look at the second example, we're going to do the same thing. We need a square root between these half numbers. So let's pick the whole number that we know in between. So that's 8. And the square of 8 is 64. So 64 is our number that has a square root in between 7.5 and 8.5. And our square root is 8. Okay, our last example of problem solving. So we have a square picture. So we've got a picture and a frame. Lovely little sailboat. It's the SS Culligan. And so it says the picture has an area of 100 meters square. So the picture has an area of 100 meters square. Okay? And it's mounted on a square piece of matting. The matting would be this outside piece in red. That's the matting. Okay? Kind of like the border in between the picture and the frame. So the matting has 2.5 times the area of the picture. If the picture is centered on the matting, what width of matting is visible around the outside of the picture? So basically what we're saying is, I want to know how much is this length, or this length, or this length, or this length, from the picture to the matting. Okay, well let's start by what we do know. So we've got a little picture, and we know that this area is 100 meters squared. That seems like a massive picture, if I'm saying. Let me go centimeters, because that seems like more realistic. And we're saying that the entire matting has an area that is 2.5 times the picture. So picture times 2.5. So 2,500 centimeters squared area. Okay, that's the matting. And so we want to know what amount of width is showing. So we need to think, okay, well, what are the side lengths of each of these squares? Because we know the area, we can find the side length. So to find the side length of the picture, we're going to take the area and we're going to go square root to find the side length. So square root of 100 is the side length. 100 is a perfect square. So the picture has sides that are 10 centimeters. So the picture is 10 centimeters by 10 centimeters. We're going to do the same thing for the mat to find out the length of the sides of the mat. And so again, area, take the square root of the area, we'll find the side. So square root of 2,500 centimeters squared. And when we square root 2,500 centimeters, oh, I just put too many zeros. My bad. That should be 250 centimeters. That was better. When we square root 250 centimeters, we get 15.8 centimeters in length. So, going back to this picture, I'm going to erase a little bit here because it's getting a little crazy. Okay. We know that here to here is 10 centimeters. And we know that this full length is 15.8 centimeters. That's rounded. And we want to know what are those little lengths in between. Okay, so we've got a big length, two little pieces plus 10 equal 15.8, right? So question mark plus 10 plus question mark is going to give us 15.8. Well, if we take off the 10 from both sides, that means we have two question marks are going to equal to 15.8. So let's cut it in half. Let's see what one question mark is worth. And when we go 15.8 and we cut it in half, or divide it by 2, we get 7.9 centimeters. So what width is visible around the outside of the picture? Well, 7.8 centimeters on each side of the picture will be visible. 7.9 centimeters on each side of the picture. Okay, so that's it for your formal notes. I am going to add a third page, just doing some reminders about perfect squares and non-perfect squares, but this is optional. So if you want, you can stop now or you can carry on. Okay, so a few things I just want to say about perfect squares and imperfect squares. A perfect square can be expressed as the product of two equal rational factors square roots, or the square root of a perfect square is exact. So then square roots, or the square root of a non-perfect square is an approximation. It is an irrational decimal. So it was like the ones when we looked in decimal form that did not end, they did not terminate, and they did not follow a predictable pattern. So that is it for lesson 8, and that is it for chapter 2. You are done your first unit.